Hello everyone, my name is Anshli Khandelwal and I am one of the SRE from the SRE team. Today I will be sharing insights into AP egress private link connectivity using the push model. Let's get started. So first of all, what is the push model? In the push model, the AP control plane hosted by the Red Hat initiates the outbound connection to the customer managed hop nodes and execution nodes using the automation mesh over TCP port 27199. Key characteristics of the push models are the control plane initiates the connection. Communication is secured using mutual TLS. Connection targets the customer hop nodes and execution nodes. And there is no inbound internet exposure is required on the customer side. If we compare it with the pull model, so in the pull model, customer managed nodes initiate outbound connections to Red Hat, while in push, Red Hat initiates inward connection to the customer. Why do we use AWS Private Link for egress? So, AWS Private Link enables automation traffic to remain private and secure while staying entirely within the AWS backbone. It has few benefits like no public internet, no requirement for public IPs, there is cross-account connectivity support, and there is explicit allow listing of AWS principals, which means customers maintain full control over which accounts can connect to their endpoint service. So let's understand the egress flow better. Suppose we have two VPCs. One, it is Red Hat Managed VPC, and the other is the customer managed VPC. On the customer side, the we have the network load balancer, and this network load balancer is associated with the VPC endpoint service. The customer shares the endpoint service name with the Red Hat, and on the Red Hat side, a VPC endpoint is created using the customer endpoint service name. Once approved by the customer, a private connection is being established between these two VPCs. When the mesh ingress node initiates a connection over TCP port 27199, traffic flows through the VPC endpoint, reaches the customer NLB, and gets forwarded to the hop node or execution node. This allows Red Hat to execute automation jobs on customer managed execution nodes without exposing them to the public internet. All communication remains protected using end-to-end MTLS. So there is the setup process. So on the customer side, customer needs to provision a NLB in private subnets, create a VPC endpoint service backed by the NLB, and enable the private DNS. And then they need to share the following information through a Red Hat support ticket, which is endpoint service name, AWS account ID, and the AWS region. Then on the Red Hat side, they need they need to create a VPC endpoint in the control plane VPC using the provided service name and share the generated endpoint DNS name with the customer. Then on the customer side, this is the final configuration where they need to approve the incoming endpoint connection request, and also in the meantime they need to configure split horizon DNS so the endpoint hostname resolves privately. Then they need to validate the connectivity. Once complete, the mesh ingress node can securely connect to hop and execution nodes over TCP port 27199. Now, for this demonstration, I am using two AWS accounts. Account ending with 468 represents the Red Hat control plane environment, and account ending with 997 represents the customer environment. So as you can see, that I have logged in into the 997 customer account, and there I created this VPC where there are two private subnets and there are two public subnets, and There are two route tables as well created for the private and the public subnets as well. For the private subnet route table, I have created the NAT gateway, and for the public route table, I have created the internet gateway. Before jumping to the endpoint service name creation, let's understand how many instances are needed. So as you see that I have created two instances. One, I am using it as a hop node, and the other one I am using it as an execution node. Then this is the most important part where I'm I have created one NLB, which is network load balancer, and in the private subnet, here you can see two availability zones, and I have created three listeners as well. One for TCP/22, which is for SSH, one for TCP/80, which is for HTTP, and one for TCP/27199, which is for receptor. Then also we need to copy this. Customer needs to copy this DNS name and create a CNAME record against this DNS name into their hosted zone section. After that, we need to create one endpoint service again using this load balancer which we just created. And in this load balancer, we need to make sure that it is also available in these two zones. Then we need to copy this endpoint service name which is being created and copy the region in which this VPC is being created, as well as share the AWS account ID on the Red Hat support ticket. In the meantime, what Red Hat will do, let me just go to that other account in which the Red Hat control plane AAP is deployed. Okay, so here you can see that in this we have this AAP is deployed, which is using this name. Okay, there we will create one endpoint and let's see like if the connection has been made or not. We will see. Okay, just give it some name, test private link endpoint. Okay, then we need to select the type as endpoint services that use NLBs and GWLBs. Okay, and then here we have to put the service name which is being provided on the support ticket. So I have the service name with me. Let me just copy it. Okay, this is the service name. We just need to verify it. So you can see it has been verified. Then we need to select the VPC, the AP's VPC, which is this. Then we need to select the subnets. Make sure we need to select the private subnets. Okay, so I'm selecting the private one subnet, and the other one is for private two. Okay, and here we need to select the security group, which I have created for the where I have mentioned some inbound and outbound rules, which you can modify accordingly. Then here I am initiating the connection. As you can see, the endpoint request has been generated. Then we need to go to that. Then we need to go again to that customer's account. Okay, let me just go to that account again. 9971 in which customer VPCs is deployed. Okay, in this account, we can see the endpoint request. Okay, so in this service name, before that, before that request, we need to make sure that we have mentioned, like we have been asked from the Red Hat side that the AWS account ID in which the control plane is deployed, and we need to mention that ID in this list. Okay. After that, we can see that this endpoint connection request is here. So we need to accept this request. And after it may take some time. So you can see the connection has been made and it is successfully in the available state. So after this connection has been made, we can see clearly the instance list. We can see the instance name in the instance list, and you can see this, right? So it is being created using the host name, using this host name for which this is the host name which we have uh, created in the when we have created the CNAME record against the NLB's name. Okay. Let me just now we are in the Red Hat control plane, and this is the execution node which is deployed on customer's instance. And on this instance, I am deploying the job. So this is my demo job, which just uh, print the hello world. Here I'm using this push group. In push group, I have associated my instance with this. Okay. So this instance has been created with this instance group. So right now I'm running this job on the execution node. So let's see. So as you can see, the job has been successfully done, and that's how we can validate the connection between the control plane to the customer's environment. And there is no public internet exposure and there is no use of any public IP.